This video is going to talk about determining if the inverse of a function will also be a function, and then finding that inverse algebraically also. So we're going to look at what's called the horizontal line test here. And the horizontal line test just says exactly what we did with vertical line test, but if you can draw a horizontal line through the original function that intersects two or more points on the graph, then the inverse is not a function. And it's the word not there. So for example, if I take a look at the first one, I draw a horizontal line, it intersects twice, so the inverse is not a function. That's going to be the same thing with our next one. 1, 2, 3 times potential, so the inverse is not a function. And then our last one, which is a line, original graphs for all of these are functions. Again, a horizontal line test. This time it intersects only once, so this one, the inverse, is a function. So we're going to use our graphing calculator in combination with coming up with our answers algebraically to determine if an inverse is going to be a function, and then also to find what that inverse will be. So if we take a look at our next page, we're going to first look at our graph f of x equals 2x squared minus 5. Remember, this is the same as saying y equals. We can almost get our process started because that's what we're going to be putting into the calculator. All right, so let's take a look at putting in 2x squared minus 5. Notice every time I click a button it turns red, so you can kind of follow along with your own calculator and see what's happening. Make sure you hit zoom 6. Remember, this is going to put you on a standard window. Okay, so you're going to see here, let me just actually change this to our large screen. We get this U-shaped graph. We're just going to sketch this on our paper. Okay? So I'm going to move back to my screen. Here. Do a quick sketch. Let's use a different color. Now, using that horizontal line test, this inverse would not be a function. So inverse is not a function. What that will mean is when we go to find the inverse, we really shouldn't be using inverse notation at the end. So remember, finding the inverse, we're going to switch our x and y, solve, now when we get to this point, we're going to be square rooting both sides of the equation. When you square root, you get two answers, which would end up being the two different parts that would make this not a function. So technically, plus or minus, or y is going to equal plus or minus the square root of x plus 5 over 2. The only part of this that would be a function is if we only put the positive part of this. So this is the inverse. That, using function notation, the positive part would be the only part that would work for the inverse function notation. Now if I ask you for the inverse, you do want to give me that information. We can't put the function notation since it's not a function, but that's something that you want to pay attention to. Okay, in our last example for the graphing, this is going to be kind of a longer video, which is okay. We're going to graph g of x equals 3 square root of x minus 1. So it's going to be y equals 3 square root x minus 1. Let's go to our calculator and kind of check out and see what that will look like. 12 totally forgot what it was, x minus 1. Now if you do what I just did and did not delete all this other stuff, you're going to have to go through and do that. Sometimes it's just easier to clear it out and retype it. So 3 square root x minus 1. We'll hit graph since we already know what that's going to be on a nice screen. Now notice we get something similar, but we only get half of. So that's that positive side of the graph I was just talking about. So here we're going to draw, starting at this point, your graph. If you do a horizontal line test on this, the inverse is a function. So we are going to switch our x and y. We're going to start solving by dividing by 3. We're going to square both sides here, which will give us x squared over 9. And then we'll add 1. Now technically the inverse is only going to be the positive of this graph. Something we're going to focus on in other units when we do inverses is we're going to talk about what that means in restricting our domain when we get into our graphing component. For now, we're going to just put f inverse, actually it's g inverse, I'm sorry, of x is equal to x squared over 9 plus 1. And that's basically it for the graphing component. And I know this was a long video, so just make sure you kind of stop and start it as you go and get these notes taken down.